Hello dear students, this is from the third term, that is sets, lesson 6 sets, and that is in the previous class, that is in 7th standard also you have studied about sets, and here we are, and what are sets? Set is, we know about what is the definition of a set. Set is a well defined, that is set is a well-defined collection of objects. Okay, set is a well-defined collection of objects. That is in your class. For example, in your class, there is a collection of that is a group or a collection of the names of students starting with A. That is in your class. So many students in your class starting with their names EA. That is Amrita, Archana, Ashwin, etc., etc. That is a well-defined collection. And for another example, that is a collection of that is tallest students in your class. Collection of tallest students. That is, we can't that is, we can't collect the tallest students. That is students with the students are with the that is, your age is up, that is for 13 or 40, that is the students are with the different heights, so that we can say that there is not a well defined means, that is we can correct that if it is we can say that there is A is equal to the starting with the letter A, the name starting with the letter A, Archana, Ashwin, and etc. These are all letters starting with the EA. And here that is, we can write a set with inside two curly brackets. This is curly brackets, that is, this is curly brackets, and starting with the curly bracket and ends with the curly bracket. And also, that is, we can represent a set that is with a capital letter EA. That is a set of vowels. That is V is equal to set of E E I O U. That is V is equal to the this collection of set of vowels. That is A E I O U. And here, listen again. That is, this is represented by a capital letter V. Capital letter V represented by a capital letter, and here also represented with the A. And inside this set, that we can these are the elements. We can say that these are that is A, E, I, O, U. These are the elements inside a set. Here also the elements are Archana, Ashwin, and Ann. That is, these are the elements of the sets. That is this A, E, I, O, U are the elements of a set, and these elements are separated with the commas. These elements are separated with the commas. Inside the set, these elements are separated with the comma. That is A comma, E comma, I comma, O comma, U. These elements are separated with the commas, and here we can say that from this V is equal to this one, and we can say that here E is an element of V. Set V. E is an element. This represented with the element or epsilon. That is, E is an element of V, or here it is that is B is not an element, that is crossing over here, and we get, that is, we can say it as, that is, B is not an element of V. B is not an element of V. That is, this belongs to or element of. Belongs to or element. This is called belongs to. Belongs to the set. Okay, belongs to the set B or A or etc. Okay, this is what we call as belongs to, or here it is, this is not belongs to. Crossing over here, that is, this is not belongs to. Not belongs to V. That is not belongs to V. That is, this is called belongs to or element of, that is AE is an element of V, or B is not an element of, that is called not an element of V. These are the that what we studied in the previous classes. What is a set and the elements of a set, and it is represented by a capital letter, and whatever is that is the it belongs to or not belongs to. Next is subtopic is representation of sets, and we can represent the sets in two forms, that is one is roster form and second one is rule method or set builder form. First is roster method or tabular form. In this method, in roster form or tabular form, we can represent a set in inside curly brackets, that is A, B, C, and closing with a curly brackets, and we are writing the elements in a set by using commas. This is a roster form, that is set of whole numbers. For example, set of whole numbers less than 5. Set of whole numbers less than 5 is equal to, that is set W. Whole numbers is equal to whole number, that is W, that is 0, 1, 2, 3 and 4, that is less than 5. So that we can write it as W is equal to 0, 1, 2, 3 and 4. That is the form of a roster form. This is roster form or tabular form, that is writing the elements inside two curly brackets. Writing the elements of a set inside two curly brackets and is separated by commas. You see, roster form. And also that is if it is for example, Allahabad. That is, we know that this is a place, Allahabad. And what is the set? That is the elements in where, that is we want to write the elements in this set, that is Allahabad. That is, here it is, there are how many elements are here? That is A, L, A, H, A, B, A, D. Okay, how many elements are here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That we know that what is the elements in a set, that is in a roster form, the elements are not repeating. Here we can write it as, here A is equal to, how many elements are here? That is, how many A's are here? That is 1, 2, 3, 4 A's are here. So we are writing only one A. Okay, A is common. And then for 2 L's, we are taking 1 L and comma, and then H is here, and B is here, and also D, and closing the brackets here. That is, these are the elements in the name, the Allahabad. Okay, second one is rule method or set builder form. Here we are not writing the elements, actual elements in this like this form, that is in the roster form. That is, here we are writing only a statement or the form of the method of the in the roster form. That is for example, that is equal to, let A is equal to set 1, 2, 3, 4, 5, 6. Okay, 5, 6. These are, that is, this we know that this is in the roster form. A is equal to set of 1, 2, 3, 4, 5, 6. And this is in the roster form. How can we write this in a rule method? That is equal to, we can say that A is equal to set of X. The elements are representing by X such that, if this is, that is, this is such that, okay, such that, the symbol is such that, X such that X element of, what is it? These are starting with 1 and by using commas, that is, elements are 1, 2, 3, 4, 5. That is, we know that these are the elements of natural numbers. And what is it? X, that is, this X is less than 7. X is less than 7. That is a form of, no other forms here. That is Ex, these elements are representing with X, and X such that X are element of N, natural numbers. These 1, 2, 3, 4, 5, 6 are elements of natural numbers, and also X is less than 7 up to 6, that is X less than 7, closing the bracket. This is the rule method. This is the rule method. Only the rule is writing here. The rule is only x. The elements are represented by x, and the x is what is x. X is represented by, that is with the n, elements of n, and then x less than 7. This is the rule method. Okay, this is from the exercise question 6, from the first exercise, and this question, that is 6th question. Write the following set in roster form. This is the first question, and this is the first set of questions, and this question is 6th question. And what is it? A6 is equal to x such that x is equal to n by n plus 2 and n element of n and n greater than 5. And what is it? X. What is x? X is equal to n by n plus 2. X is equal to n by n plus 2. And n element of natural numbers, and n greater than 5. N is greater than 5. So we should take after 5. That is, first of all, take 6. And here what is it? N is equal to 6. When n is equal to 6, what is it? X is equal to 6 by 6 plus 2. And what is it? 6 by 8. And reducing this, we get that is equal to n is equal to 3 by 4. Okay. First element is 3 by 4. And then after that, n is equal to, second one, when n is equal to 7. N is equal to, taking n is equal to 7. And what is it? X is equal to 7 by 7. That is substituting the value of here. That is why we take 6. That is n is greater than 5. N is greater than 5. So we should take n is equal to, that is after 5. That is 6. First of all 6. And then put the value of 6, and that is in this formula. That is x is equal to, value of x is equal to, the elements are, we know that all the elements are x. That is the elements of a set, we can say that it is x. And what is x? X is equal to, using this formula, that is n by n plus 2. That is in that builder form. And we should write in the roster form. X is equal to 7 by 7 plus 2 is equal to 7 by 9, and is equal to, that is n is equal to 7 by 9. We can't write it in the least form. And then after that, it is when x is equal to, n is equal to 8. 8 is equal to, x is equal to 8 by 8 plus 2 is equal to 8 by 10. And see, x is equal to 8 by 10 is equal to 4 by 5. 4 by 5. Dividing by 2, we get 4 by 5. And when last one, n is equal to 9. N is equal to 9. X is equal to 9 by 9 plus 2 is equal to 9 by 11. And x is equal to 9 by 11. 9 by 11. And what are the elements of that is x? That is element of A6 is equal to, I am writing here, elements of A6 is equal to 3 by 4, 7 by 9, 4 by 5, 9 by 11, etc. Okay. 3 by 4, 7 by 5, 4 by 5, and 9 by 11. These are the elements of A6. Okay, next question. Second question, write the following sets in set builder form or rule method form. Okay, set builder or rule method form. And the second question is V2 is equal to 11, 13, 17 and 19. This is in the roster form. And how can we write this in the set builder form? That is V2 is equal to set, what is it? X such that x element of, this is natural numbers, x element of natural numbers, and that is x element of natural numbers and or prime numbers, x element of natural numbers, that is x is prime numbers between, or x is a prime number between 10 and 20. Okay, x is a prime number between 10 and 20. X such that x element of n in natural numbers, and x is a prime number between 10 and 20. That is here it is 11 and 9. That is in between 10, and after 10 it is 11, 13, 17. These are all prime numbers. This is in the set builder, that is in set builder form. And the second question is B4 is equal to, that is question 4, B4 is equal to 8, 27, 64, 125 and 260. And what is this? Yes, these are the cubes of, that is cubes of 2, 3, 4, 5 and 6. And what is, how can we write in that set builder form or rule method? There is a rule here. What is it? Cubes, that is x such that x is equal to n cube. X is equal to n cube, and in between, that is x element of n, the capital letter, that is whole numbers, natural numbers. And we can say there is a rule in between here, that is what I said, that is 2, in between 2 and 2 less than or equal to n less than or equal to 6. 2 less than or equal to n less than or equal to 6. That is this, these elements are in between 2 and, that is including 2 and 6. That is 2 cube is equal to 8. That is 3 cube is equal to 27. 4 cube is 64. 5 cube is 125 and 6 cube is 216. This is the rule method. That is x is the elements x is equal to n cube. N cube and the numbers, the cubes of a numbers. That is x element of, that is this natural number. Sorry, yes, natural numbers. And one more rule, that is this is in between 2 and including 2 and 6. This is the set builder form. Okay, next question is from 3. Set 3, that is first question is 1, 2, 4, 16, 64 is equal to x such that x is a factor of 32. And why? Give reason. Is, there is a question, that is what is it? Is 1, 2, 4, 16 and 64 is equal to x such that x is a factor of 32. That is, this is in the, what is first of all, that is in the roster form, and this is in the set builder form, that is rule method. And what is it? That is the question is that is these are all the factors of 32. What are the factors of 32? We know that the factors of 32 are 1, 2, 4, 16, 8. That are all factors of 8, 16 all are factors of 32. But 64 is not a factor of 32. That is 64 is greater than 32. So that we can say that 64 is a factor of 32. And what is the reason here? 64 is not a factor of 32. 64 is not a factor of 32. That is, this is the first question. Okay, that is from the set 3. That is the sixth question is x such that x square minus 7x plus 12 is equal to 0 is equal to, the factors of this equation is 3 and 4. Is the factors of the quadratic equation x square minus 7x plus 12 is equal to 0. That is, we know that what is, this is a second degree equation, that is x square minus 7x plus 12 is equal to 0. That is, we have already studied in the previous classes about that is second equation or quadratic equation or polynomials, etc. And here, how can we solve? That is the fact that we know that there are factors of a second degree equation. There are factors for a second degree equation. And here the question is 3 and 4 are the factors of the second degree equation. How can we solve? And we know that is, how can we solve a second degree equation? By splitting the middle term method. That is the easiest one. That is x square. That is, what is it? How can we split this? That is, we need, when we add, we need 7. Adding, that is, we need minus 7, and we multiply, we need, what is it, 12. And what are the digits here? That is minus 7, that is minus 4 and minus 3. That is minus 4 plus minus 3 is equal to minus 7. And when we multiply, that is minus 4 into 3 is equal, minus 4 into minus 3 is equal to plus 12. That are the fact, that is the, when we split minus 7x, that is we get x square minus 4x minus 3x plus 12 is equal to 0. Okay, and then and grouping these two, that is we get, that is x is common here. X is common here, that is taking x outside, that is x minus 4, and here also that is 3 is common there, that is taking minus 3 outside, that is x minus 4, and we get x minus 3 and x minus 4 are the factors, x minus 3 and this, and here also the common, that is x minus 4. And what I said, x is equal to 3 and x is equal to 4. X, that is x minus 3 is equal to 0, that is x is equal to 3, that we know that. What, and then x minus 4 is equal to 0, x is equal to 4. And the factors are, what are the factors here? Factors are 3 and 4. Factors are 3 and 4, that we can say that the 3 and 4 are the factors of x square minus 7x plus 12 is equal to 0. Next is, let's see the elements of the following sets. And first question is x such that x square minus 2x minus 3 is equal to 0. Again, this is a quadratic equation. We want to solve this and find the elements of find the factors of this quadratic equation. The quadratic equation is x square minus 2x minus 3 is equal to 0. And we want to find the two factors here, that is multiplying or adding, that is minus 2, that is minus 3 and 1, minus 3 and 1, and splitting the middle term, x square minus 3x plus 1x minus 3 is equal to 0. X square minus 3x plus 1x minus 3 is equal to 0. And taking the common outside from this, here it is x is common here, that is x minus 3, and here plus 1 is common here, that is x minus 3. And here what is it? X plus 1 and x minus 3. And the factors are, first of all, x plus 1 is equal to 0. That is equal to 0. X plus 1 is equal to 0 and x is equal to minus 1. And here x minus 3 is equal to 0. X is equal to minus 3. And the factors are minus 1 and, sorry, this is plus 3. Minus 1 and minus 1 and 3. Minus 1 and 3. Okay. And the fourth question is x such that x element of is set integers and x square less than or equal to 4. X such that x element of integers and x square less than or equal to 4. And what is it? X square less than or equal to 4. That is x element of integers. And how is it? That is less than or equal to 4 x square. And how can we take this? In which integers we can take the squares? That is, first of all, that is, this is 4 also. That is when x is equal to 4. That is root of x square is, that is equal to, x square is equal to 4 and x is equal to root of 4, that is equal to plus or minus 2. Plus or minus 2. And then when next one is take x square is equal to 1. That is x is equal to root of 1. We get plus or minus 1. Okay. And there is only, next we get the square 4. That is, we get 4. The square 4, the square root of 4 is equal to 2. And we get the exact square is equal to integers. We need integers, so that we need only the exact squares. That is, x square is equal to 1. We get the exact square 1. And then next it is only 0. When x is equal to 0, x square is equal to 0. X is equal to root of 0. And we get 0 itself. Root of 0 is equal to 0. And the elements in this set is equal to, that is the integers plus 1 and minus 1. That is minus 2 plus 1 plus or minus 2. That is minus 2 minus 1 0 1. Here is a 1 there and then also 2 there. The elements of this set is equal to minus 2 minus 1 0 1 and 2. And that is, what is it? What is the condition here? X square less than or equal to 4. So that we can take 4 also. That is, and the square we can take the square root of 4, and next number is, no, we can't take the square root of 3, so we take 1 for 2 also, so we take 1 is equal to square root of 1 is equal to 1, and the next is x is equal to 0 and the square root of 0 is equal to 0, and the elements are minus 2 minus 1 0 1 and 2. Okay, I hope you enjoy this class. See you in the next class.